Hello, today I'll be dealing with cerebrospinal fluid. Formation, circulation, and absorption will be the headings I'll go through. Absorption will be a separate video. Before we start, let's look into the previous year university questions that came from this topic. Basically, CSF was asked as a short note in 2019, which means you have to write everything from the functional anatomy of the ventricular system to the clinical aspects. What I'm going to discuss will be a small part of your answer. So before we get into the formation of CSF, let's discuss the functional anatomy or the ventricular system of brain in brief. So basically, we have lateral ventricles, third ventricle and fourth ventricle. Lateral ventricles on each side are connected to the third ventricle by foramen of Monroe. You have the lateral ventricles here. This will be the third ventricle. This will be the fourth ventricle. This is the foramen of Monroe, and the third ventricle is connected to the fourth ventricle by the cerebral aqueduct of Sylvis. This was discussed in the functional anatomy part, so this is just a revision. If the lateral ventricle, foramen of Monroe, third ventricle, cerebral aqueduct of Sylvis, and then the fourth ventricle. Getting back to this, the formation is majorly by the choroid plexus, which is around the ventricles of brain. This contributes to about 2/3 of the total CSF. Choroid plexus is around the lateral ventricles are the major contributors. Then the epidermal surface of ventricles. Epidermal surface are basically the epithelium of the ventricles, the outer epithelium of the ventricles, that produce about 1/3 of the total CSF, and a small amount is also produced by perivascular spaces of blood vessels. This will be dealt with in detail. First, let's look at the choroid plexus. Choroid plexus is basically, you can say, you have cerebral arteries here, which will form cauliflower-like projections which also have a layer of epithelium with microvilli over it. What did I say? You have cerebral arteries will form cauliflower-like projections, and it will have a covering of epithelium over it, and the epithelium will have what? Microvilli. The cerebral arteries which contribute to this are majorly the internal carotid artery, the basilar artery, posterior inferior cerebellar arteries. That's it about the formation of CSF. The rate of formation is basically, it is given, a different value is given in different textbooks. The one I'm following here is Guyton and Hall. I have the rate approximated to be 550 ml per day, while the CSF volume in the whole ventricular system of brain is only 150 ml. So 550 ml is produced per day, but 150 ml is only found in the whole ventricular system. So where does the rest go? Which will be dealt with during absorption, which is the basic principle of absorption. Now let's talk about the mechanism of formation. Mechanism can basically be divided into two: passive diffusion and active transfer. Passive diffusion is nothing but basically passive diffusion of plasma through the choroid plexus. You have the cerebral arteries here. As I said, they produce projections which form the choroid plexus. Basically what happens is that plasma filters through it passively without the use of energy, which is basically passive diffusion and the formation of CSF. Active transport, you don't have to go through the mechanics of it. Just learn that Na plus K plus ATP is formed, chloride channels and aquaporins are involved in it. Let's look at the composition of CSF in brief. CSF, as I said, it will be a product of the plasma, product of the blood, right? So it will have both water and solid components. Water will be 99%, solid will be 1%. Solid will have both inorganic and organic components. These exact values are not important. You can learn these by just reading from this slide. Now circulation is the most important part of today's video. You have to remember the functional anatomy which was discussed before. So as it was discussed before, I'm going to start right through it. So circulation starts from lateral ventricles. Why? I've mentioned that lateral ventricles is a major site of production through choroid plexus, right? Production of CSF through choroid plexus. So basically lateral ventricles, and then it passes to the third ventricle through foramen of Monroe, then to the fourth ventricle through cerebral aqueduct of Sylvis, and fourth ventricle will have three openings: foramen of Leschka on lateral sides, two foramen of Leschka on lateral sides, and one foramen of Magendie on the medial side. This will all have a common opening into cisterna magna, which will further go upwards to subarachnoid space, and then which will be reabsorbed by arachnoid granulations into dural venous sinuses. This is the absorption part which will be dealt with later. Basically now you have to just learn this sequence. This is as easy as it gets. Just remember that after it ends on cisterna magna, it goes upward into the subarachnoid space, and it is then further reabsorbed there. To get a better understanding and visualization, let's watch a video based on this. As you can see here, the lateral ventricles are producing CSF, which is now being transported to the third ventricle, which has now reached the fourth ventricle. And as you can see, as I've said before, it passes upward to the subarachnoid space. You can see the arachnoid granulations here, which will absorb it into the dural venous sinus, which is majorly superior sagittal sinus. So that's it. Thank you.